Hello again, I'm back, and today we're gonna talk about black holes and what is needed for a black hole. We need a supermassive star, about 8 times the mass of our sun as minimum. Minimum, anyway. So it goes through a nuclear fusion, yeah, and it turns hydrogen into helium and other much heavier elements. And at some point there's just no more fuel anymore, no more hydrogen. So it starts to die out. So the outer layer, it like flies away. That's called a supernova. But the core, if the core is dense enough, the core is dense enough, about 2 to 3 times the mass of our sun, just the core. If we are lucky enough, the core will collapse into itself because it will die out, because there's no more fuel. So the gravity takes over. If the gravity takes over, it also means that the gravity takes over. There's much more gravity, much denser. It starts pulling everything close to itself, and that becomes an event horizon. I have no idea if I'm even writing this right. The horizon. Let's just say I am. The event horizon is what nothing can escape from, not even light. That's why we see it as black, and there's a photo of black hole, because it sucks all the light in, so there's no light, and so if there is no light, you see black. So in science, black is not a color, but in art, black is. So now you kinda know how black holes are born. It needs to be about 8 times. The sun has to be about 8 times the mass of our sun. So when the fuel, as hydrogen, runs out, there's no more fuel. It will just start to die out because there's no more fuel. There's no more fusion to do. And when it dies out, the core is remaining, and it has to be huge for the gravity to win and collapse into itself, and then becomes the event horizon if it's just strong enough, the core, you understand? I hope you do. So the thing about black holes, they are not vacuums. You have to know, they are not just vacuums. They are not sucking things out, in, because there is no such thing as, like, it doesn't suck. It's just big with enough mass. So let's say that the moon is pulling. I mean, the Earth is pulling moon to itself because it has mass, and it's also moon is pulling Earth, but Earth much more, but not enough for it to collapse into Earth. So the black hole is doing the same. It's pulling with its own gravity. It's not sucking things out of nowhere. It's not traveling around the fucking universe to suck everything, to eat everything, to just consume everything until everything dies. It's not like in the movies. It's like normal physics. There's also supermassive black holes, and we are going to be right back into that. So supermassive black holes. You have to know what is a solar mass. So our sun. Oh shit! Starting try out. Our sun equals to 1 solar mass. So how many solar masses do you think a supermassive black hole has? Whatever you say, you probably will be wrong. If you're right, be happy about it. But a supermassive black hole, supermassive black hole. It's about, let's say, well, all the information said it's about hundreds of millions of solar masses to billions. So let's just say about 800 million solar masses. So they are big, okay? They are what are like in the center of galaxies, eating gas, stars, and even colliding with other black holes. And about the collision of black holes, we are gonna talk much later. There's also one other black hole type, and it's primordial black hole, if I remember right the name. But it's like just a theory, because they were born about in the beginning of the universe, in the Big Bang, okay? They were super small, about the size of atoms, very dense, and they probably die out very fast. But let's just say that black holes have a bunch of energy. Even if I took a coin and turned that into a black hole, the energy that would release would destroy a city. So even those little atoms would like, maybe not destroy a house, maybe a room, just the size of atoms, even smaller. Their born and destruction will just destroy like a room or even bigger. So they were much smaller, lived much shorter lives than regular black holes. And black holes, they are actually pretty normal, I would say, because they're black. We cannot, if you look at the night sky, you probably cannot even see. But if you could see all of the universe, you will see much. So they are pretty normal. Our sun will never be a black hole, and the closest black hole, it will not kill us in millions, maybe even billions of years, if you're lucky. Don't be scared. The black holes are too far enough that we will never ever die because of one. And that was explaining from me to you today. Bye bye.